Hello everyone, welcome to data structure class. Today I am going to explain regarding arrays. Okay, so it is the second chapter of the first module. In the array, you already know it is an linear data structure which holds all the homogeneous element. I can say it is a collection of a similar data items, and each elements in the array are stored sequentially, that are one after the other. So each one will be stored at particular location. It starts from 0. So it can say that subscript or index. Okay. Then the first element will be stored at 0th location. Second element will be at 1 location, and so on. Then this one already seen. This representing a two-dimensional array. Here I will be the row, J will be the column. Then here cells of I comma j at that particular row and column, the value will be available. Then now the main concept starts from array operation. We are doing separate operations like traversing through the array, inserting an element at particular position in the array, deleting an element from the array, searching for the particular item in the array, then sorting the elements ascending order or in descending order. So, as I told, traversing means visiting each of the nodes, or you can say each of the elements of an array. Okay, in this in order to perform this, uh, we can make use of either for loop, while loop, do while loop, then if or switch statements. Then we can traverse from left to right, or you can traverse from right to left. Then uh, initially I have taken one example. I am allocating the 5 elements of an array. So how to allocate? Data type followed by an single variable which holds all the similar data types. Then it contain I am allocating 5. It means that 5 elements are allocated. So the index will be from 0 to 4. A of 0 to A of 4 to hold 5 element. So initially the subscript will be I equal to 0. Then up to where? Here n is 5. Then 4 means 5 minus 1. You can say 5 n is 5. 5 minus 1 is 4. Okay, then how to access or visit each of the element? In this above code I can read each of the elements separately. Scanf percentage d ampersand a of 0, this will read the first element. Then similarly a of 1 will read second element. Similarly 3 4 5 will read these 3 elements. So uh, this is the one way of reading the element, but it is an time consuming task, and we have to write each of the element. Reading and writing separately become uh, more code to be written. So instead of that, I can make it in a shorter way by using the for loop. Okay, so how to write the for loop is that for initially we start from the 0th value. So I equal to 0, up to how many values you have to read? Up to n minus 1. So 0 1 2 3 4. So n minus 1, so you are keep on incrementing the value. So for I equal to 0, I less than n minus 1, I plus plus. Then read the value. Scanf percentage d, we can make use of a of I, or you can make use of ampersand a of n minus 1. Both remains same. Then we can how to we can make use of function to create an array. So traverse through the array by using a function. So the same one, for that we required we have to pass 2 arguments. One is an array with the size. If you want to mention size, mention here, else it will take by default. Then number of elements we are going to insert, that is n here. Then the remaining things are same as that of this. Then how to display an array element? This function is for reading the element. Then how to display it? Only replace that scanf with printf for printing each of the elements of the array. Then second operation is inserting an item into an array. So in order to insert an element into array, we need to check that whether the size is available or not. Okay, for example, here I have taken n equal to 8, means 0 to 7 is the size of an array. If I am going to insert one more element at the next position, that time it is not possible. Why? Because the array allocated is only from 0 to 7, it can store up to 8 elements. If I go for the next position, that time it will not consider. Okay, so you can say that the position can be 8, this one is position is 9. If I start from 0, that time it becomes 8, this time this one becomes 9. So if it is greater than the allocated value, that time it can represent it is an invalid position, or you can't insert it. Similarly, if it is less than 0, that time also it is not possible to insert the element. Then uh, so now how to insert the element at particular position. First we check that whether it is valid or not. We can able to insert the element or not. If it is more than array size, that time it is we can't insert. If it is less than 0th location, that time also it is not possible to allocate. Those two are invalid position to insert the element. Now next is I want to insert an item at particular position. So this is the position where I'm going to insert the element. So I'm going to insert the new element 90. For example, I'm going to insert an item 90 at position 3. So 0, 1, 2, 3. Actually position becomes 4, but location is 3. At this position I'm going to insert the element. Then what I have to do, if I want to insert the element, if I want to insert the element at this position, then first I have to move the 80 element to the next one. So first shift all the elements from right right, then come up to the position. So that first shift the 80 to next place, 70 to 7th place, 60 to 70, then 50 to 60. Then at this place we are going to insert the element. Okay, that is why the we are traversing from last bit to till the position. So first we step is that move the value from the 7th location to 8th location, 6 to 7 location, 5 to 6 location, then 4 to 5th location, then it becomes empty. That time we are going to we can able to insert the element. So same thing written here. First a of 8, initially it is empty. Now I am going to store which value? A of 7. So initially it is empty. Now I am going to store this a of 7 value into it. So I'm done like this. Similarly I've done all the remaining position. So I'm shifting all the values. Then in general I can write if it is I is if it is I plus 1, then it is I. So if 7 is I, then 8 is I plus 1. Similarly, how many positions we are moved down from the last bit from I equal to 7 to, just look at here, from 7 to we move to third position. That is why 7 to third position. That is why if it is n minus 1, 7 is n minus 1, because 8 elements are 8 in the location n value. Then 7 minus 7 to position is 3. So we are decrementing the I value. Initially it is 8. Once we copy the value from 7 to 8, again we decrement. Then we copy the value from 6 to 7, like that. So I equal to n minus 1, that is I equal to 7. I greater than equal to position, it is 3. Then I minus minus. Then uh, here at the this position, then a of I plus 1 equal to a of I. So a of I plus 1 is at this position. I'm going to store a of I value. So I'm copying here. Then similarly we are doing for until I is greater than equal to position. That is I greater than equal to position 3 matches, the loop will be continuously executed. When I value becomes I value with less than 3, that time this will get stopped. It means that it will come at this position. If it is goes below this, the loop will get come out of it, and this element will be at this position. I am going to insert an element item a of position. So a of position, what we got? 3. At this 3 position I am going to insert what is the item? 90. So I am going to insert 90 here. Then at the end I am going to return n plus 1 value. So earlier n values are taken, but now I am adding one more value to the existing array. That time it becomes n plus 1. So this one is the entire step-by-step code is written like this. The first one, we required an array, how many elements we are going to insert, then at which position I am going to insert the element. So initial check that position is greater than n minus 1. So at that time also we can't insert the element. If position is less than 0, that time also we are not able to insert the element. So we can't insert the element. So return whatever the elements are there, return as it is. So return n value. Similarly, if the position is available, we are going to insert that particular location or position, then we go for writing this function, then return the value. Then next step is that deleting an element from an array. So similarly, for how you are checking the condition for inserting the element, here also we need to check the condition for deleting an element. If I said delete the element a of 8, because the size is up to a of 7, we can't the element at a of 8, which is not allocated. Similarly, if I want to say delete the element at 0 position, that less than 0 position, that time also it is not possible. So these two are invalid position. Then next, out of this a of 0 to a of 7, 8 element, I want to delete particular element at particular position. So if I am going to delete the 40 item at position a of 3, so that time I can directly delete it, because no one check for the condition. Already allocate values are there. Go to particular location and delete it. Item deleted equal to percentage d at which position a of position. So if I mentioned 3 here, that 40 value will be deleted. Then just compare the previous insertion operation and deletion operation. What we are doing in the insertion operation, the last we go to the ith at the last element, we are just pushed one to the next element, the previous will be pushed to the next one. But here if I deleted this element, this entire sequence will be shifted back to this, so that these will moving towards this side. So I will be moved from previous one, I will be decremented, now I will be incremented. So at this position, a of 3 equal to a of 4, a of 4 equal to a of 5, a of 5 equal to a of 6, then a of 6 equal to a of 7. So that is why previous one we were incremented and here decremented, but now here decremented, a of 3 equal to a of 4. If I is 4, then 3 becomes I minus 1. So the value changes from 4 to 7. 4 to 7, that is 4 is the position is 3 plus 1, position plus 1, then 7 is n is 8 minus n minus 1. Okay, then we are just incrementing the I value, so that I equal to position plus 1 from here to till the last one, up to where element out to last element, means that n minus 1. Keep on incrementing and check for the values. Once the value is less than this condition fails, you come out of that loop and return n minus 1, because we have deleted the element from the existing one, so it becomes n minus 1. The same is written in the function. Then in the next video, I am going to explain regarding uh, searching and sorting operations. Okay, so go through the video so that in the next interaction class, queries will be arised. Okay.